Hello. In this Labtube, I will show you how method of inverse matrix to solve a linear system works. Through this example, there's a linear system of 3 equations, 3 variables, and I want to solve it by method of inverse matrix. The method of inverse matrix is the following 3 steps. First step is that you form the matrix form of the system. So form AX plus B. In other words, find a coefficient matrix and find the right-hand side matrix. Then step 2 is find the inverse of the coefficient matrix A. Well, here is where restriction for this method comes in. This method works only for matrices for which you have inverse. In other words, first, it should be a square matrix, meaning that the number of equations should be number of the variables, and then the matrix should be invertible. So if those are the case, then you can find inverse by forming this augmented matrix and then row reduced echelon form this augmented matrix. If A is invertible, you will end up identity in the left-hand side, and the right-hand side, you will get A inverse. The matrix you will get after doing those elementary row operations to get row reduced echelon form, that matrix is A inverse. Well, when you find it, then it's done. The solution is given by, you just multiply A inverse to the right-hand side matrix, or the constant matrix, B. Well, let's see what are, let's apply those steps here. So what is the coefficient matrix? So the coefficient matrix is put the coefficients of first equation in the first row, second in the second row, third equation in the third row. So 3, 7, 3, 1, 2, 1, 9, 18, 8. Well, what about the right-hand side matrix? This is just take these numbers and put them in a column matrix, 3 by 1 matrix. Well, I found that, A and B. Now I want to find the inverse of matrix A. And to do that, I have to start making this augmented matrix. So I have 3, 7, 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then I have 1, 2, 1, and then 9, 18, 8. Well, I have this augmented matrix, and I want to transform it to row reduced echelon form. Well, I have to choose one of these entries in column 1 to be my leading one. To avoid the fractions, any fraction, I will choose this one to be my first leading one. So that's my first leading one. Then I have to put it in the right place. The right place is the first row, so I need to exchange row 1 and row 2. So, well, I will have 1, 2, 1, 0, 1, 0, 3, 7, 3, 1, 0, 0, 1, 0, 0, 8, 18, 9. Then I use this one to make these guys 0. For that, I can use multiply row 1 by -3, so row 1, -3, and then add it to row 2, so row 2. This will change row 2, so row 1 will be the same thing, 0, 1, 0. And row 2 will be 0. -3 times 2 is 6. 7 minus, this is minus 6, and then add to 7, you get 1. Negative 3 plus 3 is 0. Negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, added to 0 is negative 3, and this is 0. Well, I have to get rid of this guy also, and I'm going to do it in the same step. So I will multiply row 1 by negative 3 and add it to row 3. Sorry, I multiply row 1 by negative 9 and add it to row 3. So then I will get 0 here. Minus 9 times 2 is 18. Added to 18, I get 0. Minus 9 times 1 is negative 9. And added to 8, you get negative 1. This negative 9 times 0 is 0. Added to 0 is 0. This is negative 9. And this is 1. OK. I'm done with column 1. I found my first leading one, and that's it. Now let's do the second leading one. So this is my second leading one, and I have to make everything else in that column 0. So the first thing is that I have to make this guy 0. To make that 0, I need to multiply this by negative 2, add it to row 1. So row 1 minus 2 times row 2, you get 0, 1, 0, 1, negative 3, 0, 1, negative 9, 0, negative 1, 0, 0. OK, so negative 2 times 0, 0 added to 1 is 1. Negative 2 times 1 is negative 2 added to 2 is 0. Negative 2 times 0 is 0, add to 1 is 1. Negative 2 times 1 is negative 2. And negative 2 times negative 3 is 6. Added to 1 is 7. Negative 2 times 0 is 0. Added to 0 is 0. Well, I'm done with the column 2. This is leading 1. Everything else is 0. Here now I have the last leading 1. I have to make this one to leading 1. So I do multiply row 3 by negative 1 to get 1 in that place. So I get 1. I don't change the other rows. So I will have negative 3, 0, 0. Multiply row 3 by negative 1. This is 1, 0, 9, negative 1. OK. I'm almost done. This is leading 1. I have to make everything else in that column 0. This is 0 already. I have to make this guy 0. So let me do it here. So if I add, multiply row 3 by negative 1, and add it to row 1, then I'm done. So I will get 1, 0, 1, 0. Row 2, I don't change it. Row 3, I don't change it. And then I multiply row 3 by negative 1 and add it to row 1. So this is 0, this is 0. This is, this is negative 2. This is negative 9 multiplied to 7, negative 2. And a negative minus negative 1 is 1. Added to 0, you get 1. Well, this is identity. That means the right-hand side is the inverse of the matrix. So A inverse is this guy, negative 2, negative 2, 1, 1, negative 3, 0, 0, 9, negative 1. I found the inverse of A. I'm done with the step 2. Step 3 says the solution is just multiply matrix A inverse to matrix B. So the solution would be this guy, negative 2, negative 2, 1, 1, negative 3, 0, 0, 9, negative 1. You multiply it to B, which is 0, 1, 2. Matrix multiplication. This is 3 by 3 matrix. Multiply to 3, 1 matrix. You get 3 by 1 matrix. And the first entries, you multiply this to that. This is 0, negative 2, plus 2. This is 0. This is, now this multiplied to that. 1 times 0 is 0, negative 3. This is negative 3. This times that, 0 times 0 is 0. 9 times 1 is 9. Minus 2 is 7. That's it. That's the solution. And very quick wrap up of the method of inverse matrix is that you first find coefficient matrix on the right-hand side B, A and B. Find inverse of A. It should be a square matrix. It should be invertible. And you have to find A inverse by doing AI, the augmented matrix, row reduced echelon form. You have to end up with I something. That something is the inverse of A. You pick up that inverse. Then the solution of the system is you multiply A inverse to the B, the matrix B, the column matrix B, and you will get the solution. 0, negative 3, 7.